one button, and it will open and close the thumb so that you can do a number of things. Inside is one 9.5-volt battery, a piece of plastic, and 5 paper clips. Really simple. We have, and the electronics, or the electricity, is built into the chassis. We have 16 chassis kits, 45 minutes from here, on their way in to here. So we have time for an assembly workshop sometime in the next 48 hours if people are interested. I think it's a really good science project. So it's got a little bit of logic, it's got a little bit of electronics, and so on. But we also think we've got a device which is sort of hitting a funny sweet spot in being somewhat anthropomorphic, self-contained, lightweight, and, as Skip will explain, particularly good if you don't have a good hand to put things into your gripper. So Skip, I think, is going to talk about the background of this, the logic of it, and take it apart. If we have time, I might show off the paper clips and the batteries and the assembly process, and that will be it.
Okay.
Mr. Skip.
So you've all seen a gripper hand that is a passive prehenser that can hold things that you place into the grip with your other hand. And we were interested in helping people who don't have an other hand. So bilateral amputees need some mechanism. So I've got a left and a right, and all right. And oh, this one goes fast.
We had a little girl who wanted to stack cups. That was her big ambition when we said, what do you want from your arm? So this is a
Anyway, this
cup
takes
stack.
practice. That'll be the challenge tomorrow, so you can learn to stack cups. But I wanted to show you what's inside. I'll take this one. Be quiet. It's held together with screws. We played with holding it together with just snap together features, but decided that we're not ready with that yet. It's not quite reliable enough. But on the inside, and I'll pass this around, is something that looks a lot like a regular gripper, with 2 halves. And there's a regular 9-volt battery, a little gear motor from China that costs $12 if you want 2-day delivery from Amazon Prime. If you're willing to take the slow boat from China, it's $7. You come in a month or less. And you can see how it works. You push the button, and this paper clip makes contact with another paper clip, and all the electrical connections are made with the paper clips. So a guy in California who is Doug Bittner, came up with this basic architecture, and we've been playing with it for almost a year now to get it to this point, and we're loving it. But it's basically 2 switches, and we were using micro switches to begin with, and then we used a switch out of a flashlight, a push button switch, and I made some videos about that. And then we decided we could do it with just paper clips alone. And so I'd like to pass this around and or walk around with it, John, and let people see it up close.
So let me just tell you what to look for. There's a cam which does 2 interesting things. One, of course, is it moves the thumb. The other is it comes around and it pushes this little pole apart. The pole is part of the stay-on circuit. So the magic, and you got to think it through and watch it a few times, is that once you press the button, the cam allows the stay-on circuit to function. So the motor goes a full rotation until the cam hits the pole, tells stay on to stay off, and it stops again. So there's a little logic switch built in, and you can play with it and see how it goes.
No electronics,
Yeah, no electronics, no micro switches.
no soldering.
What's the advantage of that over your previous version that had like a flashlight circuit?
It's a little cheaper and a little simpler.
Do they have a function as well?
Yeah, I've got one of those too.
Because that one looked pretty good when you showed it.
This is like that, it's, because we're using a 9-volt battery, it's got more power and
Oh, that's right.
more duration than the AAA do.
The motor that we've been using is rated at 3 volts. So they're very tolerant to both the voltages. You know, get your torque. Specify from 2 to 30 RPM. For a 3 volt motor. Run it on 9 volt. And we get the performance from AC. And these two devices.
This circle, as long as it's closed, this circle, down there's a closed circle, and now it will open again and stuff.
Oh, yeah, that's pretty smart.
That's on time fine. And we're still experimenting. The spring that we're using, we can get from Amazon also. Or you can get it from Moto Gripper.
Video?
So you 3D print the chassis wheels.
Yes.
So what is the total cost per device? Total cost per device is $12 for a motor, $1 for a battery, probably $1 for the other metal parts. And
It's
your
under
cost,
$20. I mean, it's fairly lightweight, as you can see. It's not twice as much as the devices for those ones. But it's got all the battery, the electric stuff, all of it. You screw off your hook, and you screw on.
Skip and John, remind me, how many open closes was the max that we got during that one test?
well, the one time we pushed
We
it,
run at 10,000,
10,000.
and I've got it set up, I'll set it up tomorrow. You can see it on the label.
Clearly, the whole scene
That's
is
something
not
we have next year, but we're not about
well, that's right. And as a matter of fact, at this point, the chassis becomes the guide for bending the paper cups.
Exactly.
Well, the chassis is the jig. That's the point. And if you'd like, I'm just going to show you what the assembly looks like. As I say, we'd be quite happy to do hands-on tutorials later. But I've been doing this so much, it's become something of a obsession. Pardon me?
Absolutely.
to try that on our own.
Oh, yeah. Yeah, and I've actually got some nice diagrams and video.
Should we lick it?
You can do that too.
Figured all the parts,
I haven't tried it.
I have.
Tell me what this is.
Here's that thing, I like, so it's kept jumping.
Oh, yeah, no, that's when I was like.
Battery,
this is, like,
the
super
motor that
cool.
you're choosing, there's 4 different
And I
kinds of
just like,
motors.
honestly, like the simplicity
Of
of
that-
it, like,
that-
I'm gonna
that
use
style of
it, so
motor,
I'm
there's
gonna
4
use
different
it as
gear
kind of
ratios.
intro to
We're still
certain
playing with
aspects.
different gear
Yeah,
ratios.
so you gotta figure out which, have you figured out which gear
No, so
ratio
is this
works
to
best?
only put that
Also,
correct,
there's like 30 of them listed on Amazon.
You have 30 now? Wow.
30.
You have 3 to 30. Wow.
But the ones that go up to 1,500 RPM are
Yeah.
not of interest to us.
Yes.
And so 10 to 30 seems to be, when
It's
you
like,
boost the power up
driving,
to 9 volts instead of 3 volts, you're actually getting
Yes, I can see that, yeah,
4
the exposure rating and everything, it
come on,
60
would be nice to put it in that
4
black.
seconds.
man.
1 second. Like you'll see these things do.
How long is the
This
battery?
one
life?
I've seen it and played with it.
We don't know how
But it's
much
still one of my favorite things to play with.
Something like 1 month to a year.
But
Really?
thousands of actuations.
1,000, okay.
Because the battery is only providing power while the motor's running.
Right.
Unlike the one that run on an Arduino.
They're requiring-
running the battery all the time.
So these are the same?
Yeah, it's the same. One is just faster, one's slower, and that's just we use different motors, so it just provides different torque. I think is what he said. I'm not super clear. I'm betting it's probably that's but it's the same. It just
The voltage is the same because you're both coming from the 9 volt battery. So it's probably just a
yes,
different motor.
yeah.
Yeah, I mean, one month is.
That's nuts.
Yeah, we used to use 4 paper clips. They really wanted to keep it 4, but we had to up to 5.
Oh no,
I
wow.
know.
Who's gonna afford this?
No, they got a spring. This isn't a pen spring, right? These are springs that you bought. This is a spring.
It's not from a pen.
No, it's not. That's not. We've gone beyond that.
That would have been really cool. You need a certain kind of
Yeah,
pen.
no, very long.
Yeah.
This is great. I started printing this about a month or so ago.
Playing with it, you say?
I started printing it. I
Oh,
printed
really?
it used based on the Tinkercad that you guys shared. But I never got around to actually making the whole thing because I
It's
was so
evolved
busy.
a lot since then, as you can see.
Yeah,
But
yeah.
it's we're calling this 1.0. It's ready for you.
Yeah.
How robust is it? Like if I drop it?
What's that?
How robust is it? If I drop it or smack it against the table? does it still
Well,
function?
if it's closed, I
Yeah.
think it will survive.
Okay.
If
yeah.
it's open right now,
Not so much, yeah. But it wouldn't be, so it doesn't. That's a non-issue.
well, that's right. That's right. But if it turns out part of the paperclip origami is getting it so that once it's bent, every piece is sort of stressed into place. The most delicate part are these contacts, or the motor contacts,
Yeah.
are easy to break. But you see, we've got them sort of pierced and supported, and then the chassis sort of locks everything in place.
Yeah, it's very. How long does it take to assemble? For you to do it, as someone who's done it many times.
It took you 30 minutes last time.
Yeah, but now I know how to do it.
That's still really good.
Yeah. 20 for the chassis, another 10 for the put all the big components together.
Wow.
Giving that it is
Wow.
that way.
Cool.
All right. Maria here. Any other questions? Because we are done for now.